Hey guys, Buildzoid here, and today we're going to do a very silly video. As you can probably tell from what we have on this in this GIMP file, Buildzoid's perfect motherboard. Yeah, we're going to go over what my theoretical ideal motherboard would look like. And I've just kind of decided to do this after doing the PCB breakdown of the X570S Master because I just got so annoyed while covering that board of. Partially because of having to talk about things like M.2 slots, which is like, just read the bloody manual. What like, I still do it because otherwise I get comments from people complaining that I only talked about the VRM. It's because, well, the VRM isn't in the owner's manual. It isn't covered in the manual. But, though I didn't really put too much attention into the VRM on the X570S Master. Anyway, that doesn't really matter. The point is, so yeah, while making that video, I was like, I was getting frustrated at the fact that it was like, oh, this is another one of those Gigabyte motherboards that it's like, I like everything about this except they chose the wrong chipset. Or when we look at the B550 motherboards, we've got a lot of say the B550 Aorus Master. I like so many things about that motherboard except the fact that it doesn't have two X8 PCIe slots and it doesn't have, it has the dumb version of Gigabyte's dual BIOS. So that just disqualifies it as a good motherboard. Then we've got the B550 Vision D-P, which does actually sort of everything I want, but it doesn't have an SLI license, which is why I have a B550 Strix XE, but that thing's terrible at memory overclocking. So you can sort of see how, it's like I have multiple different AM4 motherboards because not one of them does everything at the same time. Like, there's always some minor little thing that it doesn't do. And it's just like, yeah. So here is the B550 monstrosity that would address all of that. So basic feature set, we'd have a clear CMOS button, postcode, dual BIOS with a switch, just one switch, none of this smart dual BIOS shit that Gigabyte likes to do, just dumb dual BIOS with a switch. Power button, reset button. So basically, here's where I'd have the clear CMOS button. Then we'd have power, reset, BCLK up, BCLK down, and BCLK step size. And you might be wondering about why would you want the BCLK buttons. It's pretty convenient for doing memory validations to be able to just bump up the BCLK on the motherboard. For CPU ratio with Ryzen, you would really want to be adjusting that through software. I was kind of considering it would be maybe neat to have some kind of CPU profile switch, but I was thinking about it, and honestly, that's just the more I thought about it, I was like, this sounds really tedious. From from implementation perspective, it would be kind of complicated to implement. Certainly doable. It would sort of build on top of the functionality of the existing active OC switcher stuff you see. You would just change what triggers that. But, so yeah, that wouldn't be too much of a issue, I guess. The main problem I have with it is just if you were actually using it for benchmarking, it would kind of I don't know that you would be that into actually using it. It seemed kind of one of those ideas where it's oh, this sounds way better on paper than it works out to be in practice. But the BCLK, this is just great for doing memory frequency validations, and, of course, this motherboard would be a 2-dimmer. I don't actually know how to design a proper memory topology myself, but, that's it's if MSI wanted to build this, or Gigabyte wanted to build this, I would really appreciate it. So they could slap one of their really capable 1 DIMM per channel memory topologies on this, and that would be the end of that. Anyway, but yeah, and then BCLK step size, because you don't always want to be, creeping around at 0.1 megahertz. That's for when you're pretty close to maxed out, and then when you're initially trying to figure out what you're doing, you'd be going in 1 megahertz steps. Now, doing this BCLK thing would pretty much require that the motherboard have a external clock gen separate from the one built into the, I actually don't know where it is. I think it's in the CPU. Basically, with modern Ryzen chips, since the 2000 series, you don't need, 1000 series, if your motherboard didn't have a clock gen, you were just stuck at 100 megahertz, and that was the end of that. You weren't changing the BCLK. So with 1000 series, you really needed an external clock gen. With 2000 series, there was a built-in clock gen, but it was kind of terrible because it only goes in 1 megahertz steps. And that clock gen has stuck around since. So that's how you can like overclock even on an A520 motherboard, is you can bump the BCLK up because there's this not very, fine, like not very granular BCLK control available from the CPU. And unfortunately, that also maxes out at 118 megahertz, which is enough for most things, but I would like to have more range, and I would also prefer, especially for memory frequency validations, I would really like to have more granularity. So 0.1 megahertz step size and a proper external clock gen, and then you could probably push the BCLK to like 200 megahertz or something stupid like that. Not that there'd be any reason to really do that. My main priority is like I just want finer adjustment ranges. 1 megahertz step size is just way too damn big. But yeah, so, and then you just have buttons, and these two things over here, those are supposed to be LEDs for indicating which BCLK step size you're on. These dots are supposed to be like the voltage read points, and then this is supposed to represent the dual BIOS switch. And yeah, for the voltage read points, it would just be vCore, SoC voltage, memory voltage, VTT DDR, and VDD 118. This is the voltage that you, on say 5000 series, you bump it up to stabilize the Infinity Fabric, and I think on 2000 series, that is the voltage that if you just, like, if you're on LN2 with 2000 series, I think it's this one. I'm not entirely sure. But basically, you go up to like 1.65 volts vCore, and then instead of raising the vCore anymore, you just raise the 1.8 volt rail to like insane levels, like 2 volts, 2.2 volts, 2.5 volts even. And like the CPU just keeps clocking higher and higher as you do that. So 2000 series is kind of weird with that, but this is a super voltage, like this is a super useful voltage to keep track of because it's just generally a useful voltage. It helps with FCLK overclocking. It helps with CPU overclocking on 2000 series when you're on LN2, and you can run 2000 series chips on B550 chipsets, so that's not really a problem. And then for the PCIe slots, I just want 4-way SLI and Crossfire support. You may notice that there's no indication of any M.2 slots anywhere, and that's because I don't care about M.2 devices. I'm not saying they're bad, I just don't care for them. Like, I do not see the appeal of attaching something with a screw to your motherboard. Anyway, also the 24 pin would have to be at a right angle because thanks to this little overclocking corner on the motherboard, that 24 pin will no longer fit in that area. So the 24 pin has to go at a right angle over here, and that's completely fine with me. Anyway, in the rear I/O, we have a clear CMOS button, and then the rest of this, like, there should be, like, one networking port, and then the rest of it will just be USB ports and audio. I'm not too focused on this, as long as there's at least 8 USB ports, right? Like, my bare minimum for a motherboard is, like, 6, unless it's ITX. If it's an ITX board, I can even tolerate having maybe, like, 5, maybe even 4, but if it's ATX, it has to have at least 6. And then for this, I would want 8 minimum. And then, 1 gig, 2.5 gig. I don't really care how many gig LAN. Well, 1 gig at least, but I don't really care past that. And then for the audio section, I don't care. Honestly, if the motherboard came without audio, I'd be fine with that. Though, as far as I know, the audio section on a motherboard is actually, I think it's a requirement. You can't exactly build a motherboard with no actual audio whatsoever. You need something, I think. And there's also some weird software issues that you run into if you have, with some stuff, if you have like no audio outputs. And there's even benchmarks that complain if you have no audio support on your system. So yeah, anyway. And let's talk about the PCIe configuration. So here's the PCIe slot layout. So slot number 1 is X16 or X8 3.0. We'll get to why that is. Slot 2, so this would be X, which is why I drew the lengths in. So this is an X16, but like X16 or X8 3.0 slot. X16 or X8 4.0 slot. X8 3.0, X8 3.0, X8 3.0, X8 4.0, and then the last one is X8 3.0. And you might be looking at this like, Buildzoid, you're insane. What the hell? Why would you do this? Well, it's very simple, and it actually can be done. Like, that's the best part. Like, you might be looking at this like, where are you getting all these lanes? See, I'm not actually getting all these lanes from anywhere. Oh shit, I drew this wrong. There's supposed to be a connection from here to the PLX switch. There. Yeah, so this mess over here, this actually is viable. So the reason why I want this is because in order to run four-way SLI, you need X8 PCIe slots, and you need a lot of them. You need 4 of them, minimum. You need at least 4 X8 PCIe slots to do four-way SLI if you're not using like GTX 690s or GTX 590s or Titan Zs or, you know, the dual-core cards. And considering that most of the dual-core cards from NVIDIA have trash power delivery, you probably don't want to be using them if you're going for like really pushing the cards for benchmarks. So we need a PLX chip because we need to get more lanes. Now, luckily, all of the GPUs that support four-way SLI don't support PCIe 4.0. So I'm not aware of a PCIe 4.0 PLX chip, but the PLX, like the 3.0 PLX chip is already really expensive, and if a PCIe 4.0 PLX chip exists, it has to be even more expensive. Like PCIe 4.0 is just generally expensive. Like the PCIe 4.0 switches, you also need PCIe, like after a PCIe 4.0 switch, you need a PCIe 4.0 repeater. You can't just have a switch like you could for PCIe 3.0. So PLX 3.0 here is actually sort of like, it's great because we don't actually need 4.0. And it's also great because it means we can just do everything in 3.0 parts, which are cheaper than PCIe 4.0 parts. But anyway, so yeah, I like in one configuration. So let's say you want to run four-way SLI, right? So your CPU, whatever CPU it is, puts out 16 PCIe lanes. Always. That's Ryzen CPUs have 16 PCIe lanes that they just sort of spit out for general purpose PCIe. So 8 of those lanes go into one PCIe 4.0 switch, and this one does need to be 4.0 because we do want the option for slots 2 and 6 to be 4.0 PCIe slots. Like if you're running two-way, right? If you're running a two-way GPU setup, you'd put one GPU here, and that would be at X8, and then you'd put the other GPU here, and that would be at X8. And yes, the motherboard would have to come with like custom SLI bridges because I don't believe that. Actually, I think that might be the NVIDIA RTX PCIe slot spacing right there. But yeah, basically you would need some extra PCIe bridges for this, but anyway, like X8 4.0, X8 4.0, and the way this would work in terms of the actual, like electrically, basically the lanes from the CPU go through this switch, they go down here, and then they go through this switch, and here. And this is how you get X8, X8. Lovely. Now, let's say you just want to run one PCIe 4.0 GPU, like a 3090, right? And you're going for maximum GPU performance out of your one GPU. Well, you just put it into the first, like, PCIe slot number 2, and the lanes basically go like this. And so you get X16 on slot 2 at PCIe 4.0. Everything is great. I'm not entirely sure how well this part of this would work, because that's 2 X8 PCIe 4.0 switches in a row. So that might be a bit problematic, but hopefully that doesn't cause too many issues. Now, the 4-way setup. Actually, no, let's do the 3-way setup. So 3-way, you would go here, and so the fun thing, actually, for 3-way, you would always want to do this. And the reason why you'd always want to do this is if you're using triple slot cards, well, they'll actually fit next to each other, right? If you're running triple slot cards. But if you're using 2 slot cards, then you also have just an air gap between the 2 GPUs, and that improves your cooling. So yeah, you'd want to be using 1, 4, and 7 for your triple GPU setups. And in that scenario, the way the PCIe lanes would go is you'd go like, ta-da, and one goes off to there. Then actually, because like that, and then we'd also have one that goes, actually, you'd have also this. Then this would go like that to slot 4? Is it 4? Yeah, it's slot 4. And then you'd have one lane that goes like that. So Yeah, so basically you can sort of think of this everything like the X16 from the CPU just sort of fuses into the PLX chip, and then the PLX chip handles it from there to create this X16, X8 monstrosity. So that's great. So we've got like best support for triple GPU you could possibly have on a motherboard. And there are motherboards that do this, like X99 motherboards offer this kind of lane PCIe slot configuration. X299 boards also sometimes do this. So yeah, like this is total, like this is not a new thing, though normally it's not done through a horrible mess of PCIe switches like I've come up with here. But this should be workable. Anyway, like the having PCIe switches before the PLX chip so that when you're running 1 or 2 GPUs, you don't have to go through the PLX, because the PLX chip adds a bit of latency. So if you're not running like quad GPU or triple GPU, you really actually don't want to be going through that PLX chip, which is why we have, slots 2 and 6 available for 1 and 2 for single and dual GPU setups. And now let's do the 4-way setup, which 4-way, of course, has the annoying slot requirements of, like, you'll need 2 slot cards, and you'll be running 1, 3, 5, and 7. And now you can see why we have this PCIe switch over here, which just flicks between slot 4 and 5. Because otherwise, like, if we didn't have that PCIe switch, you wouldn't have that really convenient triple GPU spacing. You'd have like a really you'd have a really cramped triple GPU spacing, and it's just like, we could have a not cramped triple GPU spacing. That's better. So anyway, in this scenario, again, we just take 16 lines from the CPU, going through the mess of PCIe switches before the PLX chip, and then we just go bam, bam, bam. Actually, no, this goes to slot 5, and this goes to slot 7, and you get your 4-way at X8. That's not an 8. X8, X8, and X8. And you can do all of this on a B550 motherboard, because you'll notice that I'm not using the chipset at all. Like, the chipset doesn't factor into this. The only reason why the B550 chipset is a requirement for this, as far like for this motherboard, in my opinion, is so that the BCLK overclocking isn't completely freaking broken like it is on literally every single X570 motherboard I've ever tried. So, yeah. And that's my ideal motherboard. It's basically, well, actually, so at this point, like, mostly I've been focusing on, like, multi-GPU setups, but the funny thing is, like, this isn't just limited to silly multi-GPU setups. Like, you could do all kinds of fun things, like, I don't know, have a million capture cards. Because the funky thing about the PLX, actually, you could have a lot of PCIe 3.0 SSDs on this, like a stupid amount, because the funky thing about the PLX chip is actually this thing doesn't care if it has X16 or X8 going into it. So what you could do is you could say whack an RTX 3090 on here, right? Or a 6900 XT, right? Let's not forget AMD now has competitive GPUs as well. So you can put your crazy fast PCIe 4.0 GPU on slot 2, and then that'll just run at X8. Okay, so this will go like this, and that'll run X8. And right now, you wouldn't be losing any performance in this configuration because it's PCIe 4.0. It's got a ton of bandwidth. The GPUs are going to be fine. And the remaining X8 can go into the PLX chip. And this is where things get fun, because with this X8 going into the PLX chip, you can use slot 1 for, like, I don't know, you could put a bunch of M.2 drives on here. You could put more M.2 drives here. Actually, you probably don't even want to do that, because you'd ideally just sort of go like, because normally the M.2 expansion cards are like 4 M.2s on the card. So you'd get a 4x M.2 expansion card, right? And that would just run off of the PLX chip. And as long as you didn't try to, like, RAID 0 those M.2s, you should have enough bandwidth for everything to work out. Like, yeah, as long as you don't RAID 0 them or try to read and write from all of them at the same time, you'll be fine. Like, if your goal is to just have a lot of fast SSDs available, that'll do that. And then you could also just whack more whatever, like, I don't know, you could have a capture card on slot 4 or 5. Actually, you'd probably want it on slot 5 if slot 2 has a GPU in it. Yeah, if you have a 3090 in there, you could have that. And then you could have a capture card on slot 5 and then like a networking card on slot 7 or more M.2 SSDs on slot 7. Like, I can't tell you not to put unnecessary SSDs on your motherboard. Because it's PCIe. Like, if you want whatever you want, you could put a sound card in there for all I care, right? Like, and that's the really cool thing about having just a bajillion PCIe slots is just you can convert them into anything else you'd ever want. So with this setup right here, and I guess if you got creative with the layout of the motherboard, maybe if you made the motherboard really wide, or I guess you could, so early, if I remember correctly, some early X99 motherboards or X299 motherboards did this, where instead of laying the M.2 SSDs flat on the board, they just stick them straight up in the air. Well, you know, we could just put M.2s sticking out of the board like right here. Because we do still have X4 PCIe lines from the CPU available for whatever. Actually, they're meant primarily for a M.2 drive, so yeah, you could like figure out some way to get those routed to some location on the motherboard. Because the thing is, the PCIe slots would basically, like right now, M.2 slots are normally like in between the PCIe slots, and with this monstrosity that I've come up with, there's no space between the PCIe slots. Like within a normal ATX motherboard, you only get 7 PCIe slot positions. And so, yeah, I'm not sure where the M.2 slots would go. That's kind of the main issue. It's not that you couldn't have more, like, couldn't have M.2 devices. It's just that we've physically run out of space. Now, if we made the motherboard, if the motherboard was, like, really, really wide, you could probably just have the M.2s sort of hanging out like this over here. You know, one from the CPU and one of them off of the chipset. The chipset one would be, like, PCIe 3.0, but not really a problem. If you wanted more 4.0 drives, you could put them on slot 6 for all I care. Admittedly, if you do that, right, if you put them on slot 6, you're giving up all of this stuff over here, but it would kind of be the there's just options. So many options. Like, you don't know what you're planning to do with your motherboard? Buy this and figure it out later. Unfortunately, it does require kind of a silly amount of PCIe to M.2 adapter cards. But other than that, I really fail to see any issues with this. Oh no, I do see one major problem. This PCIe like configuration would probably require, like, I'm not sure this would necessarily fit on an 8-layer PCB. That's my main concern with this. It almost certainly wouldn't fit on a 6, is my guess, because there are a lot of older motherboards that use PLX chips, but as far as I know, basically all of them have pretty high layer counts, and I wouldn't be too surprised if it was actually because of the massive amount of PCIe switches that they end up using just to... Because, like, the whole idea of having the PCIe switches before the PLX so that you can avoid it if you don't need it, like, that's not new. I didn't come up with that. Like, we have Z77 motherboards that did that. But all of those boards that do that also have very high layer counts. So, yeah, this would be a very, 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 very expensive B550 motherboard. And then for the VRM, I would actually probably go with like the VRM off of a B550 Unify X or a Gigabyte B550 Aorus Master, and then just replace all the output filtering capacitors with SP caps, not through-hole polymers. Panasonic SP caps, and that would be yeah. Like, the VRM is kind of like, there's a lot of options for how to power a 5950X, so that's not the part where I have like a very strong opinion. Because there's a lot of really capable VRMs on AM4, but it's just like we don't have this crazy... I want my wacky HEDT level of PCIe slot configurations, right? That's kind of what I'm going for. Like, basically, this is converting an AM4 motherboard into something that looks a lot like X299. Because I really like the fact that X299 just has all of these PCIe lanes. It just doesn't really have very good CPUs available for it. So this takes the best CPU currently available, which is the 15, like, well, best consumer CPU currently available, which is the 5950X, and it slaps it onto the best chipset available, which is B550, at least if you're concerned with overclocking. And then we, just add the PCIe lane capability, the PCIe capabilities of like an X299 system. Not really, because X299 actually has more overall PCIe bandwidth available to it. Actually, no, it doesn't. But the problem is that I don't know that you could convert from I'm not aware of anything that converts PCIe 4.0 lanes down into more PCIe 3.0 lanes. Right, like that's the main concern, because if you connect this, like that PLX chip, it doesn't take PCIe 4.0, it'll connect at 3.0 speeds, and so, yeah, that's kind of the thing. Like this, like ultimately, this would potentially end up being quite a bottleneck if you wanted to run like X8 4.0 worth of bandwidth through it, because it won't do that. Off of a single switch. Now, if you have both switches hooked up to it, then it'll do like PCIe 3.0 X16 speeds. But yeah, that. So anyway, like, it's not very practical. It's extremely niche and very expensive, but it is doable. Like that's sort of the main point of this video, is just kind of like, technically this could be done. At least as far as I'm aware, this could be done. Yeah, it would be like my ideal motherboard, because I could run quad SLI with a 5950X instead of, like, currently, if you want to run quad SLI, your options are X299 or Threadripper, and Threadripper sucks. Threadripper is really, really bad at everything that isn't TimeSpy Extreme. It's terrible at Firestrike. Like, the 5950X produces like 45,000 points in the Firestrike physics test. The 3960X I have literally loses to the 7940X that I have. Like, it produces like 35,000-ish points. So it sucks. Then 3D Mark TimeSpy. TimeSpy literally doesn't use more than 16 threads. So actually, X299 has an edge for 3D Mark TimeSpy, but like with a 5950X, you're not getting completely destroyed by like a 10980XE. You're pretty close to a 10980XE in terms of performance with a 5950X. 3D Mark Vantage, the 5950X does a perfectly good job there. 3D Mark 11, the 5950X does a perfectly good job there as well. The only issue the 5950X has is that it doesn't do 4-way GPU setups on any, like, well, actually no, you can do 4-way Crossfire, but you can't do 4-way SLI. Not without resorting to like Titan Zs and GTX 690s and 590s and that kind of thing. And it's like, no, I want quad 1080 Ti's with a 5950X, and we need a motherboard to do that. And it looks like this. Yeah, there. So silly motherboard things. And incidentally, like, you do just kind of get the flexibility of having a million PCIe lanes. Or more like it's not, you don't actually have that much bandwidth on this, but like, you do get the option to connect a lot of PCIe devices, and as long as you don't try to use all of them at the same time, you're fine. Yeah, and even the board, like, if you found enough space on the board, you could still probably fit the M.2 drives onto it. Actually, maybe you could do the thing that Asus does with just like a misused memory slot, and then sandwich the M.2s onto that. And that solves the board space issues, because there is kind of like, there's theoretically there should be a bit of empty space in this area between like the overclocking functions and the DIMM slots, so you could just like put a riser card in that area, and then put the M.2 drives on that. Yeah, and it doesn't have to use a memory slot like Asus does. Like, it could use like a PCIe X8. Well, yeah, you could probably whack a PCIe X8 at a bizarre angle in that area, and then just put like a regular M.2 adapter card onto it. See, PCIe is best. It's just the best. You can put it anywhere you feel like it. At any angle. Yeah. Anyway, yeah, so that's it for the video. Man, this turned out way longer than it was supposed to. I was like it's 30 minutes. I didn't know what to expect actually when I came up with the idea for this video, or don't really I guess came up with the idea for this video. Um, but yeah, so it's a really really silly motherboard idea, but it is workable, and so. Yeah, and honestly, I'd be happy to settle for just having this and then like two-way SLI and crossfire support. Like I'd be more than happy enough to have just that on a B550 motherboard. Like this you could chop off this whole PLX part of my lovely diagram and like this PCIe switch. Like you could just go like that. And I'd be perfectly happy with that if it also had all of these features. But the issue is, like, B550 Unify X doesn't have dual BIOS. What else is there? Well, that's basically it. Actually, the B550 Unify X also doesn't have this, right? That motherboard has more M.2 slots than it has PCIe slots, so I'm a huge fan of that. So yeah, anyway, I should end the video. Like, yeah, there. Silly motherboard idea. I'm not sure. Like, I don't know. I guess this is more an entertainment thing than it is like a useful information video thing. Yeah. Because, like, it's super niche in terms of, like, why I want it is, like, I want quad 1080 Ti's with a 5950X. Also, quad, like, 680s, 7970s, and I have a lot of old GPUs that, like, I would really like to be able to put into a multi-GPU setup with a 5950X. Ultimately, I'll probably end up doing that anyway with a 10980XE someday, but yeah, like, I would really like to be able to do it with a 5950X as well. Anyway, there. That's it for the video, so I guess thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch, and both Patreon and Teespring help out immensely with running the channel, so it'd be much appreciated if you'd check them out. Maybe someday I'll be able to fund the production of my crazy motherboard idea. Anyway, thanks to those. Not actually, but anyway, like, end of video. I'll go hit the stop button. Goodbye.